we are looking at derivatives as slopes of a curve. So a derivative is also known as a tangent line, which is the slope at a particular spot on the curve. And we're just estimating from what we see here. So this is the derivative symbol. It's a little prime. They would call that prime. So this is h prime of -1. H prime of -1. Get used to saying that. I really encourage it. So we'd look at -1 as an input. There it is right here as an input. Where is it at on the graph? And then you're asked to estimate what kind of slope would you have here. So looking at it, we're at kind of the bottom or top. Well, this would be the bottom. And if this was a straight line, it would be straight. So what kind of slope does a straight line have? A straight line has a slope of 0. Let's see if the next one's any different. Okay, we're asked to compare these now. Compare. Basically, the slope at 1, the slope at 1, and the slope at 6 as input. So comparing them. Is it less than or greater than? So let's go ahead and take a look. 1 and 6. There it is right here. So how steep is it at 1? How steep is it at 1? So maybe like that. How steep is it at 6? Maybe like that. So if you notice, it looks like it's growing faster here and then it grows slower here. So this is also known as like growth. So how fast is it growing? It's growing faster at 1. So that's another idea of slope. There's a lot of kind of links to what we've already talked about when it comes to derivatives. So in this case, the slope or the growth at 1 is greater than the slope at 6. It has a steeper slope at 1 or a larger growth compared to the other one. Okay. This question, see if it's any different. Estimating the slope at 10. All right, that's this slope right here. So this slope right here. How would I do it? Well, I would try to link it to some of the grid here. So I got a point here, and I got a point here, and I would say it's remember, rise over run. So this would be the rise. This would be the run. My estimate, it's always nice if you can use some of your grid or some of the graph to kind of help you with an estimate. Otherwise, you're just kind of having to guess. Notice that it is positive. We are going uphill. So I would say rise over run, rise over run. My estimate, just from my sloppy graph here, I got a rise of 2 and a run of 1, 2, 3. So that's kind of my estimate here. I'll go ahead and just, looks like they're giving me decimals. So my estimate of 2 divided by 3 is 0.66, if I remember. Yep. So this is equal to, to me, it's about 0.666, right? So let's just go ahead and take a look at our answers here. So which one is this closest to, 0.66? Well, is it 0? Is it totally flat? Nope. Negative, is it angled downward? Nope. -10, is it really steeply angled downward? Nope. 10. So remember, you can always just calculate it if you want. 10 is equal to 10 over 1. If this were a test, I'd really want to make sure. So this would be the rise. This would be the run. So it would be something like rise 10 from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, run 1. So that would be kind of the slope of a 10 line. And as you can definitely tell, my estimate was pretty good. I just wanted to kind of show you how we would kind of give it a better shot at a better estimate by just kind of comparing what we see here. If I had straight lines, that's probably how I'd do it. But out of all these answers, which one is it? Bing. Okay, so it looks like that should help you with these. I want my song. Where's my song? There it is.